Perfect. Well, thanks to you and to the Rangeland Coalition here for inviting us to be a part of this and tailing off of Carlos's comments. You know, I work for NRCS and we help our state conservationists like Carlos and their staff work with producers and implement conservation practices. And I'm really excited today to be here sharing with you a really big breakthrough in technology that I think will help us be even better at that delivery. So we're going to talk a bit here for the next half hour or so about the Rangeland Analysis Platform. And before I move on to jumping into that, I do want to acknowledge our other co-authors here on this, Dr. Brady Allred at University of Montana, who is the inventor of what we call RAP. And then Eric Jensen's also our new outreach coordinator for the Rangeland Analysis Platform that'll be helping us put this in the hands of producers and partners. So Matt, with that, go ahead and hit the next slide. So as ranchers, this is your perspective on the land, and you know it well, right? You know where the cows like to hang up. You know where the mule deer bed down. And this is this amazing perspective that you can only get by being out there every day, working the land, and often for multiple generations. Next slide. And many of you supplement that knowledge of the land with data. And you may do it in the form of some field sampling plots like seen here, going out and actually collecting vegetation data so that you can better understand how things are changing through time. And the way we typically do that is we select representative places on the landscape and go out and characterize those at a scale that we're used to measuring, which is kind of at a scale of our boots. And but it becomes particularly difficult to extrapolate with bigger and bigger pastures, right? And so we're often left struggling to fill in the gaps, like is seen here with that perspective from the hillside, our local data, and then everything in between. Next slide. And that problem gets compounded when you run a ranching operation that's often quite large, multiple pastures, and not a lot of monitoring data on the ground. Next slide. Now, if we couple that perspective on space with challenges in repeating that monitoring through time, we can see why we struggle to actually understand some of the changes that are happening on rangelands. You know, our memory is only so good, and our ability to invest time and resources in that on the ground monitoring can be intermittent, hit or miss, depending upon what's available that particular year. And so we really struggle to have that historical context, that space and time perspective on what's happening with these really large rangeland ecosystems. Next slide. Sorry for the delay here. But the good news is that technology has finally caught up. And there's been this huge breakthrough, an innovation, so to speak, in how we're able to think about and understand rangelands. And we like to joke, cowboy boots have finally meet big data. And what I mean by that is really it's like four things that have come together about the same time in the last several years that have made some huge technological breakthroughs possible. First, we have this incredible network of rangeland monitoring in this country. It's the envy of the world. The federal NRCS National Resources Inventory Program, or NRI, on public lands, the Bureau of Land Management and Forest Service also has field sampling protocols that have been going on for decades now. So we have this tremendous field validated data set that gives us an idea of what's happening on US rangelands. Then more recently, we've seen the public release of the Landsat satellite data. And if you're not familiar with Landsat, essentially there's been satellites flying around Earth and taking pictures of its surface for the last 35 plus years, providing us with this extensive and comprehensive view of what's been happening to the Earth's surface. And prior to a few years ago, that data was available on demand if you purchased it. But the USGS, the federal government, have released that data to the public. And now anyone who wants to access that can, and do all kinds of amazing analyses, research, and tool development. And the final two innovations you're probably familiar with in California, big data, cloud computing, and web services that make it all possible now to work with tremendously large data sets that would have crashed, supercomputers even 10 years ago. Next slide. So I just wanted to give you that background to say, when you see things today that we're going to show you, that's all just been possible in the last few years, and has allowed products like the Rangeland Analysis Platform, or RAP, to be put at your fingertips. And so what is RAP? Well, RAP is actually, we're going to refer to it in two ways. One is actually spatial data in the form of vegetation cover on rangelands and herbaceous biomass. But it's also a web application that makes that data available to you. So it's not just good enough to have technology and to have massive data sets, but if you can't work with them and you can't look at them and interact with them, they're not as useful. In fact, only a few specialists know how to do that. And so it's really the coupling of both the technology to produce the data and serve it up on web platforms that make it easy to interact with. That is the new exciting breakthrough that we want to talk about here today. And so anytime during this presentation, you can Google on another tab, rangelands.app, and you can kind of poke around and look at that as we're talking. Next slide. I think here I'm going to turn it over to my colleague, Matt Jones, the University of Montana, who's going to talk a little bit about the products on RAP.
All right. Thank you, Jeremy. Apologies for the delay. Apparently my screen isn't updating all that quick, but I'm an ecologist and a remote sensing scientist here at the University of Montana, working closely with Jeremy and others at NRCS to develop these products. And essentially what's on the RAP here is two major products, like Jeremy said. And the first is vegetation cover that's divided up into functional groups of perennials, grasses and forbs, annual grasses and forbs, shrubs, trees, and bare ground. And what we've done is we've combined all those plots that Jeremy was talking about, over 52,000 of them, with that Landsat imagery and some machine learning algorithms and the supercomputing power, and basically are able to now produce this land cover data, the vegetation covered data, as a continuous measure, meaning we're not classifying a pixel as grassland or shrubland. We are saying there are 40% perennials in this pixel, there are 30% annuals, and the remainder is bare ground. And we do that within every 30-meter pixel across the west. That's about the size of an infield of a baseball diamond, which you can see there, the little outline. And we do it every year from 1984 to the present. So we're now able to track changes in vegetation cover through time, the effects of management, the effects of fire, the effects of climate. We can now start capturing those things and look at the West vegetation kind of as we've never seen before. And what this has allowed us to do now is, now that we have the cover data like this, we use established models and calculations that have been around for quite some time to determine how productive is this land? What is the production on it? And then what does that mean in terms of biomass for folks across rangelands? And so what we're able to produce then is herbaceous biomass that's brought to you in units that everybody understands now, pounds per acre. In my world over here at the university, everybody talks about carbon, grams of carbon per meter squared, right? Which we don't think about cows and how much carbon they eat. We think about forage, right? And pounds per acre. So what we do is we have this now divided up even to perennial grasses and forbs pounds per acre, annual grasses and forbs pound per acre. We add them together to get a total herbaceous biomass in pounds per acre. This is also at that 30-meter resolution, so just like the infield of a baseball diamond, and it's every year from 1986 to the present. So what you have here is an example down below is, say, one location, pick your spot in the west, and you can see through time the total pounds per acre of herbaceous biomass in that location, both by perennials and annuals, for every year from 1986 up until the present. We also produce this data every 16 days. So this allows you to see a growth curve. And I'll give you an example of that in a little bit, where you go and draw an outline of your pasture for that year, and you'll be able to see the growth curve. You'll be able to see it fill in. You'll be able to look at previous years and how they compare to this year and how it's growing. So all this data is now becoming available via the Rangeland Analysis Platform. And with the sort of data explanation, I'm going to hand it back to Jeremy, who's the practitioner in the real world here.
Thanks, Matt. So we're going to spend the rest of the time talking about how you can actually use RAP. And I want to first start by just sharing with you some perspective on how I've seen people digest technology over the last few years as we've rolled this out. And there is this aversion or almost impression that perhaps technology is going to replace our field data collection and is perhaps a threat to that perspective and that knowledge. And that I want to just tell you right up front that that is not going to be the case. The way that you need to be thinking about remote sensing maps and the addition of technology is just one more spoke on a hub of knowledge. In other words, we're bringing together multiple lines of data and information in order to enhance that knowledge of the landscape that started with this producer on a horseback, just being out there on the land. And so really that's how I would encourage you to always think about any type of remote sensing product or any technology in general. Is it's just one more piece of information that can help you piece together how the world is working around you. Next slide. So the first example, or one of the use cases I want to share with you here, is just how RAP can help you better understand the inherent variability of rangelands. Take, for example, these two pastures. They both have about the same cover of annual herbaceous plants, right? About 24, 25%. But you can see in the visuals that that cover is distributed very differently across the landscape. And of course, anybody familiar with rangelands knows this, right? You walk the land and you know this aspect has different cover than that aspect. And so remote sensing data helps us fill in those gaps. Remember, I showed you the early slide about our traditional point-based field sampling. We lay a tape measure down and we sample along that, or a quadrat perhaps. But if we move that tape 5 feet, we're going to get a different estimate. And that's natural and normal. And this data allows us to better understand that variability and embrace that variability that is so important to the diversity of rangelands. Next slide. In addition to space, RAP also helps us better understand time and provide that historical context for what you're seeing on the land. This example comes to us from Montana, Eastern Montana. The BLM in an allotment had been doing some pasture monitoring. You can see in 2002, that's what the landscape looked like. And then they did the repeat monitoring in 2010, and it looks quite a bit different. More productive perhaps, or maybe it just wasn't grazed that particular year. But those estimates from those points could also be informed with a perspective using RAP data or other remote sensing data for that matter, to look at the rest of the allotment around you, what's happening. And so you can see those figures right below the photos that show how that percent cover of perennial grasses and forbs plays out on the rest of the allotment, along with the bare ground, which could be a particularly interesting rangeland health indicator. And you could look at the data and confirm and basically match up with your field observations that indeed we have seen a change in perennial cover in that time frame and a reduction in bare ground. But another really fun thing you can do is actually pull up the time series chart in RAP. And so that's what's depicted here on the left. And you'll be able to see each year all the way back to 1984, the change in those functional group cover amounts. And placed on the green line are the 2 points in time where the BLM did some field sampling. And so you can kind of put into context when you're out there on the ground and you're observing that cover change, is that due to the management, or is that just because you had a few good wet years? You know, that's the kind of thinking you can do as you bring in this perspective. Next slide. And if we want to take that even one step further, RAP can help you provide regional context for those local observations. So we're really combining both space and time in this example here. And what I'm showing you are some trends in rangeland functional group cover based on the RAP data that Matt published in Rangeland Ecology and Management here this last year. 20 years, what's been happening with these different functional groups. And you can see circled in yellow, the Northern Great Plains, you know, right there in the middle is where we had that BLM field sampling point within an allotment. Well, it turns out that blue area is part of a 20-year trend of increasing perennials and a subsequent decrease in the bare ground amount. And so there's something else happening in that particular region, perhaps climate driven, that is part of the story as well in terms of understanding our management in the context of broader issues. And I think I'll go back to you, Matt.
Yeah, so we're gonna stay up in that northern Montana moment for a second. I'm gonna give you kind of a local example that aligns with the CRCC. We did some work with the Rancher Stewardship Alliance. They're a rancher-led conservation organization here in north central Montana, I should say, up on what we call the High Line. And they asked us to sort of have a look at some of these parcels in their county, in Valley County. And they basically have a bunch of CRP expiring contracts, right? They're either just expiring, they're expiring in the next couple of years. There's about 500 of these in the county. And so the ranchers are interested and they're saying, you know, should I be re-enrolling? Should, you know, are they productive enough? Can I put cattle on? I mean, they know it for the generally, but at a big picture, you know, it's hard to track this. So using the RAP data, we zoom in onto these 3 parcels you can see outlined in red there in the north. And if you just go by soil survey data, which is useful and a nice benchmark, you kind of get these 3 static lines of saying, well, this is what it is for a favorable year, and this is what it is for a normal year, and this is what it's going to come out to about for a dry year, right? For those 3 pastures. But you don't really have the interannual information, and you don't know how they've been responding lately. Well, you can just pull these up in the RAP, and you'll get data that more looks like this from year to year. It's going to tell you which of those parcels are more productive, which have maybe been responding to precip and which haven't been, and just kind of give you more information to make that decision of, okay, I'll re-enroll this one. These 2, I might be able to use as working lands. I might be able to put some cows on there because I've got enough AUMs based on these numbers that I'm seeing now. So this gives us just one sort of more local example of how this data might be put to use. And along with these annual numbers we've been showing you, like I talked about before, you can track the productivity every 16 days. And so now I'm going to give you an example that's more in your neck of the woods. This is a parcel I just randomly picked east of Stockton, I believe it was. I was just scrolling around. My mom actually lives in Turlock. So I was scrolling around Turlock, Modesto. I ended up near Stockton and picked a random allotment and drew a polygon around it. And when you're in RAP, this is what you'll see as far as the quick analysis that's done in real time for you, where you will be able to see 16-day biomass. And the 3 lines that you see there for 2020 are perennial forbs and grasses in pounds per acre, annuals, in pounds per acre, and then the total, that blue line, herbaceous pounds per acre. And so you can sort of track this through time per the season, right? You can take one extra step. If you see this drop-down box up in the corner, you can start looking at previous years, and I'll show you an example of that in just a minute. But what you can also do is go ahead and download all of the data associated with this. And if you have a little bit of skill in Excel or another spreadsheet program, you can essentially start doing some of your own analysis. And I will do the caveat here that this will all be available on the RAP at some point in time in the near future, we hope, for sort of a reporting page. But this would be something that you could do on your own. You grab the data and you say, okay, what does this allotment look like over the last 35 years? Because we have 35 years of data. And you can see a growth curve and say, this is what the average growth curve looks like on this parcel that I've been grazing or not. And then you can look back and sort of this is sort of a good gut check that people do. And they say, okay, I remember that productive year. Let me see what that one looks like. And so you can grab that data and plot it. And back in 2005, this was a pretty productive allotment. And then you can say, oh, I remember that dry year. Let's see how it does with that. And it's tracking the dry year quite well. This is kind of 2008 was a dry year in this area. And you'll have the precip data there via the RAP as well. And so you can sort of compare these years, but then the real power is that we update this in near real time. So every 16 days, you could revisit the RAP at this coming year in 2021 and watch the growth curve develop. And so I'll give you a quick example. Let's take a step back and pretend it's the beginning of 2020. And I know no one wants to relive 2020, but bear with me. We'll pretend like it's about February 2020 and you're having a look at this pasture. Well, if you grab the data off the RAP, that blue line is what you're going to see. The most up-to-date we can get you as far as February goes of 2020. And then you can continue to revisit the RAP and see how it's doing. Right now, it seems like it's on a normal track. Well, then you check it again and now you see, oh, you know what? I'm following more of that drought year. I'm not doing as well. Maybe I need to think about what I'm doing as far as moving the cows around. And then you see it start to tick up and you can start doing this. You can track this now every 16 days on the RAP. And boom, now we have this spike. Things are getting a bit back to normal, but this year actually peaked and just kind of went straight back down. So you can really monitor this through time on the RAP every 16 days. And so with that, I'm gonna give you a real quick real-time tour. Let's hope this works just well. It's always a little bit sketchy when you're doing this via Zoom meeting. And I'm gonna go straight to rangelands.app. You can see up in the address bar, you just visit that site. This is our landing page. I'm not gonna go into a whole lot of detail on this so that we can get to sort of the meat of it, but I encourage you to visit the site. You can read about the different, the site itself and why we developed it. You can read about the specific data products and how they were built. And then on this support tab, you'll find some email addresses. Mine's there, Jeremy's there, a few other folks. If you have some questions, fire them right off to us, okay? As well as Eric Jensen. So I'm gonna go ahead and launch the app. And it might be, I know there's just a bit of a delay sometimes. So if I'm going a little too fast, maybe someone can bark at me a little bit. So by default, it comes up and gives you this sort of familiar Google Maps interface that most of us know how to work with. And what you're seeing here is the perennial foreign grass cover across the Western US for 2019. We'll have all the 2020 data updated on the RAP here in the next month or so at most. There's a bit of a lag between getting the imagery and being able to update all the data. And so this is sort of the visualization on the vegetation tab here, where you can choose any cover type you want, and it will update. You can see it for that given year. You can use the drop-down years tab to select any year from 1984 up to the present. So we'll drop back to 2017. It'll update that way. You also can do the same thing with the biomass data. I'll turn the cover data off, turn the biomass data on, and there we have biomass for 2019. And same idea, you can select a different year, see a biomass estimate for that data, for that year. And the opacity sliders here for each layer are just, so if you want to zoom into a place and you need to see the imagery behind it, you can just sort of turn it down and be able to see behind it. And I'll just point out one thing, I'm not going to go into a whole lot of details for time's sake. we have this exclude croplands development and water. And you can see that those white areas are areas we've masked out based on a pretty straightforward and basic mask, but it's not foolproof, right? Things come in and out of being crop. Things can be mapped a little bit wrong in that regard. So we give people the freedom to see everything if you want, but know that if you do an analysis over an area that might be a crop, you have to, think critically about that analysis, or it contains some development. But I'm going to keep that turned on for now. And to do a quick analysis, there's a couple options. We have uploading a shapefile, which some of you are familiar with. If you have some GIS data or whatever, you can simply upload a shapefile that you have. You'll need to zip all those files together. So I'm going to do an example of that where I'm going to click upload a shapefile, and it just takes you within your local computer. And I'm going to do a BLM allotment near the Don Pedro Reservoir, and it's going to immediately zoom right in to where that boundary is. And you can see my orange boundary here. And down here it says click the feature to run the analysis. So I'll click on it. It's going to give me the information that's in that shapefile on that boundary. And then I'm going to choose calculate time series. And a new window is going to populate right here. And what it's doing is that it's sending this request to the servers in Silicon Valley or wherever Google has the servers and the data is being stored. And it's literally on the fly and now analyzing the data within that polygon and putting it to this window over here, the results window on the right-hand side, where we can now see how annuals, the cover, has been doing through time. We can see the other functional groups as well. The blue bars are precip for this given area. And you also have the option within this analysis to turn off ones that you aren't really interested in seeing. So we're not really going to look at shrubs or trees, and we're just going to focus on bare ground perennials and annuals. So you can turn those things off and on. And like I said before, any one of these sets of data is available for download right here, so you can keep a record of it. So if we look at—
we have almost 3 minutes left.
All right, thank you. So if we look at annual biomass, you can track that every year through time. And then we can look at the 16-day biomass. Sometimes this takes a minute. And right now it's going to default to 2021, but we only have 1 day of data for 2021. So let's go back and look at 2020. And there you go, you have your growth curve. So you can do this analysis anywhere across the Western US. And for the sake of time, I'm going to do a real quick one here where you can also draw a feature. So let's say you're interested in only part of this pasture or any other location, and you're going to want to look at a spot right next to it. So I'm going to click draw features. It defaults to a polygon, but you could just drop a pin on a point if you want, or do a line. Let's say you're going to check where you did a transect or something. So I'm just going to draw a quick polygon here. And it immediately starts doing the calculation based on the polygon I drew, and is going to return the cover data. It's obviously quite similar to this allotment here, and returns the annual biomass data for that location and the 16-day as well. So you can do this for any location. You can turn obviously the opacity down here and turn on, say, the satellite layer if you want to have a look at what exactly is behind there and draw based on a specific pattern or whatever you might be looking at. And so essentially, this is the point here, is to give all this data to you folks right at your fingertips. So you can just go to your pasture, you can go to your ranch, you can get this data quickly and easily. Because one of the biggest hurdles that's always been the case is that we produce this data and it's massive. You have to have expertise or specialized software to have a look at it. But the RAP removes all those barriers and ideally brings all this data to your fingertips so that you can access and analyze any location that you like. And with that, I will hand it back to Jeremy and get back to our—
Thanks, Matt. And it looks like we're about to wrap up here, so I'll just add some closing comments. We will answer the questions in the chat box. Thanks for bringing all those up. RAP is free. It's free to go on there. It's free to do the analyses. You can even download the raw data if you want it and you know what you're doing. So that's thanks to our sponsorship from NRCS and the Bureau of Land Management and other supporters. So the last bit of advice I want to give you on just working with any kind of remote sensing products, there's some principles you need to keep in mind. a reminder that you need to be using this within a much larger rangeland decision-making framework. Remember, it's just one piece of information, okay? Use these maps to better understand and embrace that variability and really keep that error in perspective. Remember the saying that all models are wrong, but some are useful? That applies here. And so if the model estimates don't meet your expectations with reality in your area, don't throw the baby out with the bathwater. Really think critically about why that is. Maybe it's actually telling something to you that you don't know, and worth challenging your paradigm on how you think you understand the landscape. And in some cases, it's just wrong. And that's true of any type of sampling we do. They all have error. And so those would be my words of advice in working with the data. And Matt Hammond, I'm going to turn it back over to you. And thanks to everyone for your time today.